I am J. Reeves Wesley, Professor Higher Academic Grade, working for Business School in Vellore Institute of Technology, Chennai. Welcome to this introductory note on Introduction to Data Science. Organizations today operate in a turbulent environment characterized by intense competition, rapidly changing customer preferences, and increasing uncertainty. In this context, making decisions solely on intuition or judgment or experience is often insufficient. Decisions should be made based on pertinent and reliable data. Every organization is flooded with veritable amount of data, and accordingly, data science becomes an interface to transform data into useful information and draw deeper insights that could be used to make robust decisions. So what does it take for a learner in data science? A learner is given a systematic approach to addressing these challenges by transforming raw data into meaningful insights. With this in mind, the course objectives are framed. This course is defined with the following objectives: apply descriptive statistical and visualization methods on data, understand probability as a basis for analyzing risk, variability, and uncertainty in decision making, formulate and test statistical hypotheses enabling evidence-based decision making, develop predictive models using classification, regression, clustering, and association rule methods, use data-driven insights to support decision making in business, industry, and in any research setting. This course is designed to run for 15 weeks. In the first week, a learner would be introduced to data science and data-driven decision making. Second, data types, data sources, and data collection. Third week, to data preparation and cleaning and introduction to data mining tool. Fourth week, to descriptive statistics and data visualization. Fifth week, to types of probability and probability rules. Sixth week, probabilities under conditions of statistical independence and dependence. Seventh week, hypothesis testing on parametric test. Eighth week, again on hypothesis testing, non-parametric methods. Ninth, correlation that include Colpierce and Spearman correlation. 10th, simple and multiple regression. 11th, classification methods that include logistic regression and decision tree. 12th, machine learning method, that's time series. 13th, segmentation method that include cluster analysis. 14th, market basket analysis and association rules. 15th, model evaluation and validation, ethics, and emerging trends. This course contains 7 units. The first unit introduces the learner to foundations of data science. Second unit draws them to greater learning on data mining tools and descriptive statistics. Third unit throws light on fundamentals of probability and decision making. The fourth unit is on hypothesis testing, where the learners will be able to determine if there is sufficient evidence from sample data to support or reject a claim about a population. Fifth unit is on predictive analytics. The learners will be introduced to predictive analytic techniques such as correlation and regression. Sixth unit is on classification and forecasting methods. Seventh unit is on segmentation and association analysis. Learners learn on data mining techniques used to identify similar groups within data and uncover meaningful patterns among variables. Upon successful completion of this course, learners will be able to implement data science concepts and make data-driven decisions in business and organizational contexts. Prepare, clean, transform, and explore data sets using appropriate data pre-processing techniques and data mining tools. Apply descriptive statistical techniques, data visualization methods, and probability concepts to summarize data and support decision making under uncertainty. Perform and interpret parametric and non-parametric hypothesis testing methods. Establish relationship among variables and make predictions using correlation, regression, classification, and time series forecasting techniques, and draw meaningful patterns that exist in data using clustering methods. Depending on the depth of knowledge inbuilt in this course, NCRF level 5.5 to 6 could be assigned if the course is offered to first-time undergraduate students, PG degree holders, diploma holders, and working professionals seeking foundational analytical skills. A course on data science offers huge employability opportunity. It spans across industries, not just in technology firms. So, skills obtained in this course would increase employability as data analysts, business analysts, marketing analysts, operation analyst, financial analyst. So, a learner would become specialized in their own operational domain. Specifically, employability benefits for graduates include development of quantitative and analytical thinking skills, enhancement of employability across all sectors, not in technology sectors alone. They would obtain a foundation on topics in data science, business analytics, artificial intelligence, and machine learning, and their ability to data interpretation and making evidence-based decisions would improve. For working professionals, employability benefits include making robust decisions using pertinent and reliable information in all functional roles, supporting career progression into analytical and strategy-oriented positions, upskilling for data transformation and AI ML enabled workplaces. So, at the end of this presentation, I could make a suggested employability statement for this course. This course enhances employability by equipping learners with foundational competencies in data analysis, strategic reasoning, predictive analytics, and data-driven decision making. Graduates and working professionals will be prepared for analytical roles and will develop skills that are increasingly demanded across business, government, healthcare, finance, retail, and in technology sectors. Thank you for listening.